A narrow spike of radio energy, lasting just 72 seconds, once rose out of the cosmic background so cleanly that an astronomer circled it on a printout and wrote a single word in the margin. Wow! It has never repeated. It has never been explained. On the night of August 15, 1977, a radio telescope in Ohio heard something from the direction of Sagittarius that was about 30 times stronger than the normal noise of space. Confined to a single frequency close to 142 MHz, the natural radio whisper of hydrogen, the most common element in the universe. If you were designing a beacon to say, "We're here," to other civilizations, that's exactly where you might choose to broadcast. So what actually is the WOW signal? At the time, the Big Ear radio telescope was scanning the sky for narrowband radio signals, extremely specific frequencies, like a single piano key pressed in an orchestra of static. The data printed out as columns of numbers and letters, each character representing how strong the signal was above the background noise. On one line, for one 72-second window, the characters suddenly climbed 6 E Q U J 5. That sequence meant the signal ramped up, peaked, then faded as the Earth's rotation swept the telescope's fixed beam past the source. It looked exactly like a real object in the sky drifting through the field of view. Not local interference, not a glitch. But Big Ear had no way to record a detailed spectrum or to point back instantly and check. To understand why this was so electrifying, you need to know what SETI, the Search for Extraterrestrial Intelligence, is actually listening for. Space is loud in radio waves, pulsars ticking, quasars roaring, our own sun hissing. But almost all of that is broadband, spread across many frequencies. SETI looks for narrowband signals, squeezed into a tiny slice of the spectrum, because nature almost never does that. Transmitters built by technology like your phone or a radar dish are narrowband. And the WOW signal sat right on the hydrogen line at 1,220 MHz, a frequency many scientists had already proposed as a natural interstellar calling channel, because any civilization that understands astronomy will know hydrogen. So, how do you actually catch something like this? Big Ear was a transit telescope. It didn't move. Instead, the sky drifted overhead as Earth turned, sweeping different right ascensions through its two fixed beams. Each point in the sky stayed in view for about 72 seconds, exactly the length of the WOW signal. The receiver measured power in a narrow band around 1,120 MHz every 12 seconds, converting it into those cryptic characters. Background noise hovered around 1 or 2. The WOW signal peaked at the equivalent of about 30 standard deviations above that noise. In statistics language, a 30 sigma event. That's not a little bump. That's a spike shouting out of the data. Immediately, astronomers tried the obvious explanations. Could it be a satellite? In 1977, there were far fewer satellites, and none known to transmit steadily at that protected hydrogen frequency. Could it be a military signal bouncing off space junk? Possible, but the signal's clean rise and fall matched the telescope's beam pattern, not a tumbling reflector. What about Earth itself? Radio frequency interference is the bane of radio astronomy. But the WOW signal appeared in only one of Big Ear's two beams, exactly as a celestial source would when passing through one beam but not the other 3 minutes later. If it were local interference, it should have hit both beams or kept reappearing. It didn't. For decades, follow-up observations with more sensitive telescopes have stared at that patch of sky. Nothing. The mystery deepened when astronomers tried to pin down where, exactly, it came from. Because of how Big Ear recorded data, there are two possible sky positions, both in the constellation Sagittarius, not far from the plane of the Milky Way. No obvious nearby star, no known bright radio source, no screamingly obvious candidate. One speculative idea is that it came from a sun-like star with planets, and we just haven't identified the right one yet. Another is that it was a natural astrophysical burst, maybe a flare from a distant object that happened to be narrowband for a moment. But we've now catalogued many types of radio transients, like fast radio bursts and pulsar glitches, and none look like a single, non-repeating, hydrogen line-locked spike of this shape and duration. In 2017, one researcher proposed a much more mundane culprit, a passing comet. Comets have clouds of hydrogen around them, which can emit near 1,420 megahertz. Two comets were indeed in roughly the right part of the sky in 1977. It sounded promising. But when other astronomers looked closer, the numbers didn't cooperate. The comets were faint and far from the beam center. Their hydrogen emission should have been weak and broad, not a sharp, strong spike. Later observations of those same comets with modern radio telescopes didn't reproduce anything like the WOW signal. So the comet hypothesis, while creative, is widely considered unlikely. For now, the signal stubbornly resists being filed under known natural phenomenon. This is where the temptation to say aliens becomes strong. If you wanted to design an interstellar beacon, you'd probably choose a narrowband signal, at a frequency like the hydrogen line, strong enough to stand out but not so strong it fries receivers. The WOW signal checks those boxes. But science has a rule. Extraordinary claims require extraordinary evidence. One unrepeatable detection on one telescope with limited instrumentation is not extraordinary evidence. It's a tantalizing hint. If it were a deliberate beacon, why did it only appear once in decades of listening? Maybe it was a rotating transmitter that happened to sweep past Earth once. Maybe it was a one-off test. Or maybe it was never artificial at all, just some rare natural process we haven't recognized yet. The WOW signal did something important regardless of its origin. It shaped how we search. Modern SETI projects like Breakthrough Listen Now use arrays of dishes and wideband digital backends to record huge swaths of the spectrum with fine resolution, storing raw data so nothing is lost to a printer. They can check for Doppler shifts, tiny frequency drifts that would reveal whether a signal comes from something orbiting a star, rotating, or sitting on Earth. We've also expanded beyond the hydrogen line, scanning billions of channels from about 1 to 10 gigahertz, the so-called water hole between the natural noise of hydrogen and hydroxyl. The logic is poetic. Between H and OH, the ingredients of water might be the quietest band where life chooses to speak. So far, we've found plenty of intriguing blips, but every repeatable one has turned out to be human technology, satellites, or known astrophysical sources. So we're left with a question suspended in the dark. Was the WOW signal a message, a mistake, or a mirror reflecting our own hopes back at us? Right now, we don't know. We may never know. But the deeper question is this: if a single 72-second spike can haunt us for half a century, what will it feel like when we finally detect something that repeats, that encodes information that undeniably comes from minds not our own? Until that day, we keep listening, refining our instruments, and learning from every anomaly the universe throws at us, including the ones that just make us say, quietly, wow. You've been listening to Terra Nova.